Thank you for the introduction, and good afternoon, everyone. So today I'm very happy to be here and talk about the complexity of software switch integration and all of the challenges that we can see, and also talk about our approach towards standards. So before we start, I would like to come up with a small analogy that I always like to explain to my friends. So a car is like a human body. So we have all vital organs that could be also assimilated to our HPC, this high performance computer, and have all a dedicated function. Each of them are very focused on what they have to do, but they are interconnected between each other. And the same way as a human body, our car have also different types of network that fulfill also the needs of each HPC. If one of those HPC were not able to connect with it or to communicate with the other, then the same as in the human body, then we will have drastic consequences. And if we have a look on the Ethernet network, then we can see that switches are actually playing a very big role. If we get a little bit more into the detail of the elements that are actually integrating a switch, we see that we are different partners which have to work together. We are all in the same boat and have to deliver a very coordinated job, even though we are not really meant to work together as external companies. So you have the tier one, you have the OEM, of course, but we always need now more and more with the complexity to have a software team, and of course the semiconductors have also to take part of that. So today in the presentation, I would like to go and walk through one switch integration loop that we will have, and that will be the most complex part, I would say. So I need all your attention for that, even though we are just finished to have lunch. And afterwards, I want to talk about why did we go for, or we would like to go for standards. We will give maybe some two axes or direction or where the standard could go. And based on that, I would like to walk through together how the switch integration will look tomorrow with that. And finally, I also want to also explain how this strategical step is part of the BMW North Star for the all IP network. Just a short recall. Maybe you have already seen this overview. There are different ways how to interface a switch. For those who have been to the EEC last year, my colleague Kat Boldweiser already showed, okay, you have many ways how to interface a switch in an AUTOSAR project or not. That's actually not really relevant. And he made an evaluation. At BMW, we decided, therefore, to go for the hybrid switch, which means that we are using we are exploiting the potential of the CPU from the switch itself to offload it some complexity, and we rely on it for all of the initialization as well as some starting phases. And I would like to go with you through a case study that we have at BMW. Actually, it's an example of a platform that we could have for 25. It's not exactly this one, but it's really representative, where we have our HPC, which are actually fulfilling several purposes: infotainment, central computer, and then the driving. And all you can see already there is that we are giving this project to the tier one, and they have responsible for developing it. They also have integration partner that could be also with the OEM directly, so with us or an external company. And based on the different purpose of this APC, we might need also different microcontroller host, or also, in other hands, software platforms such as AUTOSAR, but also Linux or QNX. For this architecture, we decided to go for actually a simple thing for the first zonal architecture and use the same switch. And it's easier, and on the other hand, also not that easy. So let's start with this first integration. So we can actually distinguished two levels in our case study. We see that we have the system level at the OEM, where we are actually defining the in-vehicle network architecture. It means that we decided how actually which ECU will be connected to each other. We can define also some sets of network like VLANs, which communication goes on where. And then we have the other part, and that's also the trickiest part, the component level. And this is actually what we have seen previously, this coordinated team, which composed of external partner that is not always meant to work together, but for the frame of this project, will have to coordinate themselves. They have different, depending on the project, different responsibilities and deliver also different parts of the software. The handover between the system and the component is so far actually provided by generated artifact. We can see that already in AutoSAR, where we have the design of the complete system and then we give to the component artifacts. This doesn't really exist for switches, and that's why we have also non-standardized formats that we provide to the component team, and they have to manually tailor all of this information for what applies to their project in their framework. So of course, manual means that you can have actually some mistakes or some errors, and this has to be every time that we make a new integration. Later on, and we will have to use for our use case then always a proprietary toolchains that is provided by the switch vendors, and then we will have them. It will help us to make the configuration and generate a binary of it. What we have to consider also for the hybrid scenario is that we also have to rely on the firmware that the switch vendor is actually providing us. This firmware fulfills purposes for actually monitoring the switches, but at the OEM we also have some system functions that we also want to have to be supported by the switch, such as security, or we can also think about how to reflash it. There are different reasons why we need an extension on top of that. And who is actually writing this extension? There are also different ways to do, and depending on which project, we don't have any uniform responsibility there. We have observed also, and that's actually a lessons learned, that different parts of the codes are actually prepared by different people, and we have very few synergy. Even though we are using two different platforms with AutoSAR, we cannot ensure that they reuse the same type of API and so on. And that is also for the simple fact that they are different teams, they have different timelines, and sometimes you don't have time to talk to each other. And that's actually a pity, because to manage your switch, you need actually to interface it, and you need to integrate this driver in the microcontroller host. And that could be actually more uniformed. So I guess that's the main parts from the software integration, this main element, the driver in the host for the communication, the probably extension that you need on the firmware of your switch, and of course the switch firmwares. It looks a bit complicated, but they are all part of the build system for our component. And actually we have an improvement from the past, so it's not all bad. Actually, before we didn't have all of this toolchain, even though they are proprietary solution. That's still an improvement to help to modernize our architecture. But what I showed you is just an example of how the integration will work smoothly. And if we find a bug, which is always happening in a development, I think it's a little bit trickier, and we will see then shortly why. Usually this is happening when we try to integrate our system together. So not only one HPC, it's always working when you work at your own station, but as soon as you try to integrate part of the system or the complete system together, then you can see some failure. That leads us all the time to review what did we design as a system, because that could be also a problem of configuration, for sure. Maybe it could be also one of the mistakes done in this manual tailoring. And if it's not there, then they are two more critical points. And aside from the hardware, which is the highest critical point on the switch, we have also software changes that are also critical. And we always saw, okay, software, we can update it, but it's a little bit more complex than it is. Because we have a lot of dependency, we have to control also the integration, and we have to verify the compatibility. So I just want to go a little bit in detail, and then that's the only complex part of the presentation. If we just have, for instance, the firmware update, then it leads for us in a hybrid solution that we need to, in some end, rebuild the binary of the whole components, because we have to deliver software packages for components and not only for switches. We are not updating it. It's not a standalone element. Maybe a firmware update leads also to reintegrate the extension for the OEM. So that's an additional effort. The other parts that could be also adapted, and that's really depending on which update we see in the firmware, could also lead to the driver on the CPU on the host. So in that case, we really need to take several teams in place just to have one firmware update. Once we have all it reintegrated together and it doesn't have any issue, we can build regenerate the build of our software component, and then we have to validate it. So, as I mentioned earlier, maybe not all the projects are on the same timeline. So it means that if one is not ready yet to run a new integration loop, we have to make sure that the update that we have done there is still compatible with what we have already on the field. And the next step is then prepare the rolling out of the other components that still have a room to run a new integration. And the same as we had in the example HPC Central, then we will have to do again the same integration steps that we have seen before in the driving one. So maybe you are not all aware of that, but for an OEM, that's a little bit complex to have to witness all of these fixes, because we are forced also to make some homologation for our car, and software is also part of the homologation. So it means that we have tight timeline, and we have also to decide which software we will have to freeze and send to the homologation, and these steps is very costly. So aside from start of production, homologation has also another impact, and we have to make sure that not only Tier 1 delivers, but everybody has actually delivered their software parts on time, without bugs. And if we have a bug, then we have really to consider how to fix it when it's on the field. So I'm sorry for the formattation. It looks like it's not really good. Doesn't matter. Maybe just as a short summary of our case study that we have seen. I guess that you have understood that that's a really very complex way how to integrate the software, because it took a really bigger place in our subsystem. And switches are very important for supporting many functions that are not visible for the customer, but they are supporting most of them indirectly. So we should not estimate its functionality. So far, what's the main struggle is that we are not able to abstract the hardware as it is, and we are very bonded to what design is actually there. So we believe that if we could at least standardize the API and to create a more generic configuration set, then maybe we could read a little bit more of all of these dependencies and actually reduce the efforts that we have in the software integration. Because if we don't have all of these, it's a little bit more difficult to ensure to have a higher quality software and to validate it in advance. What we have to do is maybe receive, reintegrate, test it. Maybe it shows another issue, then we have to rerun again this loop again and again. In that case, that was just for the same switch. Imagine that we will have different switches in our network from different vendors. we will multiply also our risk and our struggle, I would say. So I think that you all understood why you want to go for standards. Through this generic API, I think we will have also maybe more efficiency in the integration. We will reduce our efforts, maybe improve the quality also of what we are delivered, and it's actually a great help for the bug finding phases. The other aspect of the configuration is that we could actually automate all our workflow that we had from the system to the component and reduce also their efforts. Because the components are there to develop an element that has a dedicated function that are relevant for the customer. And they are not really, they don't want to spend so much time in infrastructure. Actually, we are supposed to support them. So if we manage to have that, or actually it's the goal to make a higher hardware abstraction and provide us the flexibility. We think that actually this flexibility will increase also our reactivity if eventually for the OEM we have some crisis on the world, or we can increase our resilience. And I think that's maybe just part that is for the OEM, but also reduce also some stress if some points then we will have to face those issues. If we manage to reach this hardware abstraction, I think that we can lead also, or we can gain altogether a kind of common basis for all the participants of those types of projects, and we could also recreate a better ecosystem for the switch integration, meaning for the definition, development, integration, and validation. This whole V-member, and that's why actually we decided to go for the standard to enable then the ecosystem, but also not only to create a BMW solution, but a solution that will suit everyone, that where every other OEM could also address their issues and try to learn from each other what we have from troubles. Based on what we have learned at BMW and also asking everyone what could we improve, I think that everybody that has been working on the field, even outside of BMW, could say that there is a lot of room for improvement. And that's why I am here to try to see if there are some people who would be interested into solving those issues. So, based on that, let's see how the switch integration of tomorrow would look like on those two principles. From first, the standardized API. So remember what we have seen, all of the dependency that we have in the software. If we start to spread it with standardized API, meaning also the management protocol in some ends. So we will have compatible software, whatever updates then we want to do, and the integration part will be a little bit easier for all the parts, from the driver on the microcontroller host, as well as from the firmware extension. We will not need to put too much of an effort to reintegrate it as it's. If we have also a universal API for also the management, it means that we are also more independent on the software platform that we do have between the projects. So it's not only for AutoSAR solution, it's what we want to address. It's a solution for also project for Linux-based or QNX-based system. We believe that if we do that, we can also spare some updates, and we can also spare some reintegration loop. But also, and maybe that sounds a bit strange, but we think that we could also, depending on which country regulation, reuse also the same project and eventually spread it again or reuse this software code for other speech vendors, because you have probably heard about it, some countries and would not accept to have chips vendor for another country. So we don't want to restart the development from beginning. We can try to cherry picking the component that we have. But for that, I think that, and that's also our recommendation, is that we start to think and work on an open source project where eventually we can find a room to already address our issues and also to enable the maintenance of this software. If we have a look now on the configuration, then, as I said, and that's actually one of the biggest improvements that we could also see, is that for the system, we will be able to generate already the configuration on the appropriate format to each component. We could run also a continuous integration test whether the system is actually correct or we have a good design. But also we could extend it and reduce also the efforts on the components in a way that in a standard solution we could also use on the proprietary toolchain. So they are supposed to be able then later on to understand the formats that we use, which model we want, and adapt it to the toolchain. So about configuration and toolchain, I think that maybe the best what we could do from the OEM perspective is not to, in detail, to go exactly and tell which configuration we want and which register. That's not possible. What we can deliver is, in fact, and that's a proposal, it's actually not a must, but a feature-based configuration corresponding to our needs, what we want, or what are our expectations on certain topics like security, what is our expectation for flash and diagnostic, all of these. And we try to also have a better understanding together to which elements from the software or from the hardware it has to rely on, so that actually we can create together a better model for the configuration. This map is meant also to keep kind of translation between the OEM system until what the semiconductor vendor is also understanding for his own configuration. And it should also enable him to get still freedom for the hardware design. You will tell me that now this configuration is actually good maybe for hybrid solution, but not only. I think that will be for any kind of switch. And if we look what we have on automotive fields, yes, there is already a solution for switches. You could already put an AUTOSAR stack on the switch to solve your problem of the toolchain. However, AUTOSAR does not describe in a very good way the switch configuration. Some might find it easy, some might find it incomplete. It comes with the same limitation that AUTOSAR always deliver. And it comes with this whole ecosystem that what automotive OEM have, but the management protocol between the host and the switch will remain sometimes bounded to the stack vendor that you have, and that's still also a proprietary solution. The other aspect is that we cannot solve non-AUTOSAR projects issues with an AUTOSAR stack. That's also not possible. So we don't want to add all of this toolchain to a Linux-based project. You don't want to create new license fees just for solving the switch issues on a non-AUTOSAR project. Of course, there are also in the IT world different solutions, and we have seen it during the presentation from NXP. You might have other mechanisms that are available on the IT world. We have SMP, NetConf, ResConf. We could also associate it or try to find a parallelism to the automotive world. But yet we have not studied or nobody has agreed on one model. So it's very hard also to take a decision because everybody comes up with a solution that comes from switch vendor to tier one, and then we have also the toolchain which are also proposing something. The question is, okay, we have all of these models. What is it solving? What is it not solving? What are still the gap with those? The question that I have is also, if we have already this mechanism on the other branches, why the switch vendors, which are also selling products outside of the automotive world, has not come up with those solutions? Is there actually some limitation that we cannot adapt it to the automotive? There are also many people who have tried to establish some evaluation, pros and cons, and eventually we need also to create some KPI for that, because the maturity of the technology is one thing, and we need also to check if we can adapt it to embedded system such as a car. And we are not now in the data center. We have resources that we have to consider. Prices is also one thing, and the complexity. The other part, an aspect that is very present in the OEM, is the security. How do we cover that as well with those types of mechanisms? Maybe there is also room for an adaptation on the automotive world with some IP. That's very open. There is nothing yet written on the stone, so I guess that everybody could take part of that and eventually create an automotive profile such as we have in TSN, but that's really open. Here is actually an overview of what I brought you, all of this specification that I could find on the switch itself. Maybe there are more, probably there are more, but that's the more representative. So on the software part you have AUTOSAR, and on the hardware part you have Open Alliance. You still have IEEE for the mechanism in Avenue. So we can see that that's very complex to try to consolidate all of these inputs and try to find also something that's fulfill all, and we don't want to create way more specification that we have. So I guess that we need to consider all of this to see how can we find a room then for our issues. So how does it describe us to the North Stars, the objective from BMW? You all know that we want to go for an all-IP network, and it would make also more sense to ease our whole issue to move one day from the hybrid scenarios to a standalone way path, where the switch could be actually decoupled from the HPC development. And actually we will release a little bit the pressure and the trouble for the development of the HPC itself, so that they can focus on the customer functionalities rather than on the infrastructure. What we want to achieve with this abstraction that we want to have with the API and the configuration is that we solve the issue that we have today and help for the transition in the future generation in this more standalone item. And as I said previously, that's the open source solution is something that we really think it's necessary to be able to create a solution together, and not only one person. I need also the participation from everyone, because at BMW we have actually already some objective on the time. So it means for next year we would like to have at least our own prototype to see if it works, if it's feasible, and come up with a proposal in the Open Alliance. Eventually TC11 or a subgroup of TC11, so that for the future platform coming from toward 2029, we have already the guidelines ready for the transition, and in 2030 or coming up generation, then be able to study how to slide to a more independent switches. Okay, so here's the takeaways. Standardization for us came as a natural move or next step to solve the issue that we have today. And we believe that it cannot be only a solution that we draw, but we have to work all together for that. And of course, the participation of all of the developments parties have to be also taken in consideration. And I really encourage you to take part of that. There are already something that a point that has been raised yesterday, that maybe we need to create a liaison between IEEE and the Open Alliance. Maybe that's also one next step that we have to establish. And I hope that I convinced you that standardization is a need and a necessity that we all have, and convince also you to join us. Thank you for your attention.
Okay, thank you, Stéfany. We probably have time for maybe one question, if anyone has any. No? Well, if you think of any questions, please find Stéfany on one of the breaks. All right, thank you again. Okay, our next presentation is entitled Flexible Configurable Hardware Accelerated, How an Optimized Software Hardware Architecture Can Overcome Gateway Limitations. We have two speakers. We have Roman Pagliuca from Electrobit, and we have Tobias Islinger from Infineon Technologies. So please welcome Roman and Tobias.
Okay.
Great show, thank you.
Yeah. Okay, just waiting for the slides.
I love those BMW slides.
Okay, here we go. Okay, I want to welcome you to our presentation about hardware acceleration, a topic what we already heard yesterday, quite important for communication tasks. The question is how to make it flexible and configurable. And this is a common talk together with Infineon, a hardware vendor,